Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Foundation Tier from 2021. Question number 2 is on the topic of magnetism and electromagnetism. Magnets attract some metals. Now, metals which are attracted to magnets are known as magnetic materials. Which diagram shows the correct magnetic field pattern for a bar magnet? Now, when you're looking at these 4 diagrams, what you should be looking for is a couple of things. Do the magnetic field lines go from north to south? It should be pointing from north towards south, towards the south pole of the magnet. And it should not cross each other. And it should go from one pole to the other pole. Pole to pole. So as you can see in the first diagram, it's going from the north. These 3 arrows are showing that it's going away from the north. And the top 2 arrows are going from the north towards the south. The bottom 2 arrows are also going from the north towards the south. And these 3 arrows are going towards the south. So the first one is the correct answer. As you can see here, the middle line is going from the out of the middle point, which is not from the poles. This is going towards the north, hence this is wrong, and that's wrong over there. And let's have a look at the fourth one, and again that's wrong because it shouldn't be flowing towards the middle. Next question. Figure 3 shows an iron bar near a permanent magnet. So you have the permanent magnet with the north pole and the south pole and the iron bar in front of it. The iron bar becomes an induced magnet. An induced magnet is a type of temporary magnet where this iron bar is going to become a magnet in the presence of a permanent magnetic field. Label the poles on the iron bar. So an iron bar would naturally be attracted to the permanent magnet, so it has to be opposite poles. So a north pole and a south pole will be induced like that. The magnet is turned around so that the north pole is closest to the iron bar. Which statement about the iron bar is true? The iron bar does not experience a magnetic force. That's not correct. The iron bar experiences a magnetic force of attraction. Yes, that would be correct, because the iron bar is going to be attracted. The iron bar experiences a magnetic force of repulsion. That's not correct as well. So you just need to place a tick. You don't have to put the crosses. Figure 4 shows an electromagnet being used to separate pieces of different types of metal on a conveyor belt. So you've got piece of metal on a conveyor belt and an electromagnet on the top, and you can see anything that is magnetic is being attracted over here to the electromagnet. Which 2 of the following types of metal would be attracted to the electromagnet? Aluminium is not attracted to the electromagnet. We have to tick 2 boxes. Copper is not attracted. Magnesium is not attracted. Nickel is. So would be steel. In fact, there's only 4 types of metals that will be attracted to an electromagnet: nickel, steel, iron, and cobalt. We call these 4 metals magnetic materials. What is the advantage of using an electromagnet instead of a permanent magnet to separate the types of metals? An electromagnet only attracts more types of metal than a permanent magnet. That's not true. An electromagnet can be switched on and off. That's true. An electromagnet transfers less energy than a permanent magnet. Not necessarily. Figure 5 shows a simple electromagnet. So you have a cell and attached to the cell is a coil of wire around an iron nail. What is the purpose of the iron nail inside the coil of wire? The iron nail makes the magnetic field stronger. Yes, it does. It doesn't reduce the magnetic field to zero. The iron nail reverses the magnetic field. No. Which of the following would increase the strength of the electromagnet? Using a greater current would definitely do that. Using a shorter nail, not necessarily a thicker nail, yes. A thinner wire, no. The number of turns of wire would. That brings us to the end of question number 2, and I will see you in question number 3.